Ready to start solving some more difficult equations? Then you're in the right place. Today we'll be learning how to solve advanced linear equations. Let's jump right into some example problems. Here we have 17x minus 13x equals 20. We're trying to ultimately isolate one x, meaning get x by itself on one side of the equal sign. Since we have two terms with an x, they are like terms, which means we can combine them. 17x minus 13x gives us 4x. Then it's just a one-step equation using inverse operations to solve. We'll need to divide by 4 on both sides to cancel out that coefficient of 4, leaving us with just x equals 5 after we simplify. For our next example, we have negative 15 equals 3 times the quantity v minus 1. We are trying to isolate the variable v, which is inside parentheses here. We'll need to start by dividing by 3 on both sides. Doing that cancels out the 3 and allows us to isolate the expression v minus 1 that was in parentheses. Now there is a 1 being subtracted from v, so we'll need to add 1 to both sides to cancel it. After simplifying, we get negative 4 equals v. For example 3, we're given y plus 13 over negative 2 is equal to negative 3. The variable we are trying to isolate, y, is in the numerator of the fraction here. The entire expression y plus 13 is being divided by negative 2. So we'll multiply both sides by negative 2 to get rid of this. After simplifying both sides, we can see we were able to isolate the expression y plus 13. Now to isolate y, we'll need to subtract 13 from both sides. On the left, the 13's cancel out, and on the right, we're left with negative 7. So our final answer is y equals negative 7. For our next example, we have 2 times the quantity t minus 9 plus 4 equals 6. We'll use inverse operations, as usual, to solve. We should start by subtracting 4 on both sides. That cancels out the constant 4 and leaves us with 2 times t minus 9 equals 2. Next, we're trying to isolate the expression inside parentheses, so let's divide both sides by 2. The 2 over 2 cancels and we're able to isolate the expression, leaving us with t minus 9 equals 1. And lastly, we'll add 9 to both sides to finish isolating t. Doing so cancels out the 9's on the left and leaves us with t equals 10. For our last example, we have some decimals. Not to worry, we'll still follow the same steps using inverse operations to solve. So we're ultimately trying to isolate the v, which is in parentheses. We'll first need to get rid of the constant term. Since negative 3.7 is being added to the expression, we'll want to subtract negative 3.7 to cancel it out. After simplifying, we're left with 2.4 equals 0.6 times v minus 5. So let's isolate the expression inside parentheses again by dividing 0.6 on both sides. After simplifying, we have 4 equals v minus 5. Finally, to isolate v, we'll add 5 to both sides. On the left, we get 9, and on the right, the 5's cancel, and we're left with just v. So our final answer is 9 equals v. Wow, solving advanced linear equations can be challenging, but fun. Keep up the good work.